Hey guys, just a few reminders for us. We have our exponents and scientific notation test on Friday. Tomorrow we are going to work on specifically an exponents review, and that review sheet will be due at 9 p.m. Thursday we're going to work on specifically scientific notation review, and that review sheet will also be due at 9 p.m. I made those available to you today on Google Classroom. This way you can get a head start on it if you would like. Okay, so just gonna work here. We're gonna compute. We're gonna divide our scientific notation here. Again, I'm gonna stack them as fractions just to help myself organize. And then after we stack as fractions, we're gonna sort of regroup where we have our significands and then our powers of 10. Remember our powers of 10 here. Keep the base, subtract the exponents because we're dividing. So it's going to be 8 minus, and that's a positive 15. So it goes right there, 8 minus 15. If it were a negative 15, we would have minus a negative 15 and have a double sign. So I'm going to use my calculator. 8.4 divided by 2.4 gives us 3.5. So we've got 3.5 times 10 to the 8 minus 15 is negative 7. And I just want to double check, is this in proper scientific notation form? Yes, it is, because that significand is between 1 and 10. It's following our rules. So there's our answer. Okay, so we're going to go to page 9 in our booklet, word problems with scientific notation. As we go to do our word problems with scientific notation, I want to remind myself we only know how to do 2 operations with scientific notation. That's multiply and divide. So those are going to be our only options when it comes to these word problems. We're just going to have to figure out, oh, should we multiply or should we divide? Addition and subtraction wind up being a lot more complicated than multiplying and dividing with scientific notation. So we're leaving those operations for you guys to learn in 8th grade. Give you something to look forward to there. Okay, so let's look at our first problem. If each of the 1.3 times 10 to the 5th people employed by Walmart earned 3 times 10 to the 4th dollars last year, then how much money did the company pay out to its employees? Now, something I like to do here, because scientific notation, it's new to us, we don't have as much of a number sense with it yet to really kind of help us figuring out our operations. I like to make it into a problem I understand. So if we think about, let's say, oh, there's 30 people at Walmart, okay, and they earned $100 yesterday, then how much money did the company pay out to its employees? Oh, well, I would do 30 times 100 and get my answer. If it works for our more simplified numbers, it's going to work for our numbers in scientific notation too. So I just identified that this is going to be a multiplication problem. Okay, so we're going to wind up multiplying 1.3 times 10 to the 5th times 3 times 10 to the 4th. And all that work beforehand was just to help me figure out, is it multiplication or is it division? So now we're really just doing what we did yesterday. So we're going to group together our significands, group together our powers of 10, and multiply. Right, 1.3 times 3 is 3.9. And then our powers of 10, keep the base, add the exponents. So that's going to be 3.9 times 10 to the 9th dollars. Okay? Now, I think that would look a little bit better in standard form. So I'm going to change this to standard form. So it's money. It looks a little better. So 3.9 times 10 to the 9th, big number. I'm going to move 9 spaces to the right. So there we go. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that should be 8 zeros. Great. So we should wind up with, let's see, 3, 9, 1, 2, 3, 4, 5, 6, 7, 8. Put in my little commas there. So let's see. There we go. when we take our scientific notation test on Friday with our word problems, the directions are going to tell you to leave your answer in both scientific notation and standard form. Today in our class, we're just going to kind of get a feel for what we see as a most appropriate answer. Okay. Let's take a look to number 2. The U.S. national debt is about 1.2 times 10 to the $13 and an average personal debt of 9.05 times 10 to the 4th. So the whole country has that much in debt, whereas an average personal debt is that much, so a lot smaller. About how many times as great is the U.S. national debt than an average personal debt? So you see that, how many times as great? And we see that word times. So many times, students think that when they see the word times, it's automatically a multiplication problem, but it's not. This is actually a division problem, right? Because we're looking for how many times larger is it. If I were to think of, for example, the numbers 10 and 5, I would say, 10 is how many times as great as 5? Well, I know it's 2 times as great. Where are we getting the 2 from? By doing 10 divided by 5. Okay, so I just simplified the problem. Now we're going to use that same structure for our work, where we're going to take our national debt, that 1.2 times 10 to the 13th, right? We want to know 1.2 times 10 to the 13th is how many times as great as the personal debt. So we're going to divide by the personal debt. Okay, so I'll restructure as a fraction. Okay, separate our significand and our powers of 10. Remember, we're going to keep the base, subtract the exponents. Now let's go and do our division here. So we get 1.2 divided by 9.05. And it gives us a really, really big decimal here, 0.132596685. We're not going to write that whole number. We're going to think about the precision of the problem. These numbers are really big. Now, there's no way that the U.S. national debt is actually just 1, 2, and then 12 zeros. It doesn't end that cleanly. Same with an average personal debt. There's no way it ends clearly in zeros. So what people do when we get to numbers so large, we change our scale of precision, right? So we're going to say, we'll just keep a couple of the decimal points, and that'll match the precision of the problem. So I'm going to suggest we leave it as 0.132. And that's one of those things, as you do problems, as you grow as a math student, you have a better idea of saying, what am I going to do? I'm going to leave it as 0.132. It's not something I expect you guys to be able to do right now, but it's a conversation I wanted us to have. And then our powers of 10, 13 minus 4 is 9. So we have 0.132 times 10 to the 9th, but that's not proper scientific notation. That significand is too small, so we have to fix it. Small numbers, negative exponents, negative subtraction. So when we fix that, we're going to subtract from the exponent. We move it one space to the right, so we subtract 1, making our answer 1.32 times 10 to the 8th, and that was dollars. So there's our answer in scientific notation. Like I suggested, I think I like this in standard form better, so that's going to be 1.32. Move the decimal to the right 8 places. 1, 2, 3, 4, 5, 6, 7, 8. So that should be 6 zeros. 1, 2, 3, 4, 5, 6. So let's see. 1, 3, 2. 1, 2, 3, 4, 5, 6. There we go. And oop, that wasn't money, right? Because our question was how many times as great? So 1.32 times 10 to the 8th times as great. 132 million times as great. As you go and do your classwork, you want to identify, is it a multiplication or a division problem? Show your work, check your answer, and see would it be better in standard form or scientific notation. Okay, remember you're working on pages 10 and 11. You're going to submit both of those today. And our math joke for Matthew folks today. Why did the student get upset when the teacher called him average? It was a mean thing to say. Get it? Average, mean. Have a great day, guys.